Hey everyone! In our last project, we built a voice-controlled robot. To drive the robot, we used a couple of servos, so I thought it might be a good idea to look into how to drive servos from the ESP32. So servos come in all sorts of shapes and sizes, with some very high precision industrial versions available. We're going to be looking at low-end hobby RC servos. These are readily available and very cheap. Typically, these consist of a DC motor, reduction gearing, and a potentiometer. The potentiometer is used as a position sensor to feed back to the embedded controller and motor driver to tell it what position the servo is in. There's plenty of breakdowns online on what's inside a servo. If you Google what's inside a servo, you'll find some quite good articles. Wiring up a servo is pretty straightforward, though slightly confusingly, the colour coding depends on the manufacturer, with 3 dominant schemes. Most servos that you'll encounter will require a 5 to 6 volt supply. For the demonstrations in this video, I'm using the same power supply as the ESP32, but you might want to use a separate power supply if you are driving multiple servos or have some high torque, high current servos that you want to use. Controlling servos is pretty straightforward. You just need to provide a 50 Hz PWM signal. Sending pulses with a width of 1 millisecond should put the servo at 0 degrees. Sending pulses with a width of 1.5 milliseconds will put the servo in its middle position, which would be 45 degrees with servos that have a 90 degree range. And sending pulses with a width of 2 milliseconds will put the servo at its extreme range, so 90 degrees or 180 degrees. Now, you can go outside the 1 millisecond to 2 millisecond pulse range and overdrive your servo to get more movement range, but this can cause damage and strip the gears in the mechanism or even burn out the motor. So let's have a look at a servo in action. I've wired up my oscilloscope to the control line. You can see that we are sending a signal at 50 Hz with a 20 millisecond period. If we zoom in on the pulses, we can see that as the pulse width changes, the servo changes position. Now, we also have available continuous servos. These servos don't have a potentiometer and can swing 360 degrees continuously. With these servos, setting the pulse width to 1.5 milliseconds will cause no movement to happen. Setting it between 1 millisecond and 1.5 milliseconds will cause the servo to rotate counterclockwise, and setting it to between 1.5 and 2 milliseconds will cause the servo to rotate clockwise. The speed of the rotation is determined by how far away from 1.5 milliseconds you set your pulse width. Continuous servos also have a trim pot to let you fine-tune the dead zone pulse width. So let's have a look at one of these in action. As you can see, when the pulse width is at 1.5 milliseconds, the servo stops, and as we move away from 1.5 milliseconds, the servo speeds up. So how's this done on the ESP32? Controlling servos from the ESP32 is really easy. The ESP32 has 16 LED channels that can output PWM signals to the GPIO pins. To set things up, we call the LED-C setup function. We pass in the frequency of 50 Hz, and we pass in the resolution we want to use for setting the duty cycle. In this example, I'm using 16 bits, which will let us set a value between 0 and 65535, with 0 being 0% duty cycle and 65535 being 100% duty cycle. Once we've called the setup function, we just collect the LED channel to a GPIO pin. You can actually connect multiple GPIO pins to the same LED channel if you want, so you can drive multiple servos from one LED channel. To set the angle of the servo, we need to calculate the duty cycle. We can work out the milliseconds value for the duty cycle. This calculation assumes that you want to go from 0 to 90 degrees. If you have a 180 degree servo, then change the 90 to 180. We can then work out the value to send to the LED controller. Finally, we just set the value using LED-C right, specifying the LED channel that we want and the angle we want the servo to be at. So that's it really. It's really easy to control servos from the ESP32. There are 16 LED channels, so potentially we could control 16 independent servos. There's also several libraries out there to make this all a bit easier. You need to be careful about overdriving servos. You can get more movement range, but you might strip the gears or burn out the motors. It's also worth bearing in mind that there are more sophisticated servos available. Some servos provide a feedback wire so you can monitor the servo position, there are programmable servos, and there are industrial servos. Anyway, that's it for this video. I hope you found it useful and enjoyable. If you did, please subscribe and hit the bell so you never miss out on a video. Thanks for watching, and I'll see you in the next video.